Hi, and welcome to this tutorial about our new feature Real-Time Process Mining. I would like to give you first an overview of how it works. The central piece is the Process Analyzer Flow component. You can find it in our Warehouse sample app. The big question is, how do we get a process view out of our data? To see how it works, I am now in the Flow orchestrator of the warehouse simulation and will now open the Flow Process View Orders. Here we can see the flow, which produces the process model. We will concentrate on the Process Analyzer component, which is located in the center of the flow. The event inflow, the warehouse order event topic, is on the top left of the component. On the right, we have a timer which resets the process model every day at a specific time. The events and the timer are the input of our process analyzer. Let's have a look at the outputs. The first two outputs are the statistics of the process model. These are the total messages, the messages which are in transit, the alerts, and the utilization of the stages. These statistics flow into dashboard components and build probe streams as well as history streams. The output of the process analyzer on the right is for the generated events. Those events can be used to take actions on it. For example, do I ask here for the event shipment ready because I want to send the customer a notification when it will arrive. To do this, I set the duration as a property to the message and calculate the time and send it out as a notification. Same is for the alerts, which are also sent as a notification to the customer. So, this is a little overview of the process analyzer. Let's continue with the configuration. Let's have a look inside the component. The configuration works as in every other flow component via properties. First of all, we give it a name. Then we need to have a unique ID, the process property. This property is unique per process. Afterwards, we need to define the stage property. This is a property in each message of the process, which includes the name of the stage it is in. It is very important that every message which flows into the process analyzer flow component has those two properties defined. Next is the optional definition of the process start stages. Those are used to prevent the falsification of the process view from messages which are somewhere in the process but are sent first. If their current stage is not one of the defined process start stages, the analyzer is not recognizing them as those. Same is for the process end stages, which are also optional and define when a process ends. If you know exactly how the ideal path of your process should look like and that it has no dynamic behavior, you can define it under the happy path property from start to end stage. With this statically defined, you can see all variances and immediately identify where it is not like it should be. Without the happy path statically defined, it will be generated based on the message throughput. The key performance indicator, the KPIs, are used if you want to compare your process with a specific indicator. You can specify them with a property name and a label. As soon as you define a KPI, it is required that this property is included in all messages flowing into the analyzer component. You can also define events that the analyzer should send. Those are stage events, alert events, and link events. For the stage events, you just define the stage name and then you can create an event if the stage is created, a process checks in, or if a process checks out. We have a shipment ready event defined, which is needed to send the notification to our customers. The same is possible for the alerts. You can define the stage name, a threshold value, and the unit of it, and as soon as the messages in the stages exceed this limit, an alert is fired. Our alert here is fired as soon as a process stays more than 1 minute in the wait for product reorder stage. The link events are referring to links between stages. So if you define the source stage and the target stage, an event can be fired when the link is created or when a process travels that link. Below the events, we have the stage expiration value and unit. This is only needed if you have not defined the process end stages, so the analyzer knows when to end the process. The last thing we can define is how long the model history is saved in days. The process analyzer makes a snapshot of the process model each 15 minutes, and you can save it on a maximum of 10 days. We have here 5 days defined, which are 480 snapshots. Now you know how to configure your process analyzer. Let's have a deeper look into the event inflow of the component. Therefore, we are going back into our flow orchestrator and then in our live view of the flow. We click on the connection line between the warehouse order event topic and the analyzer component to see what goes inside. The events from the warehouse application are sent to this topic and from there to the process analyzer component. Those events are already correctly defined. Here we can see how they look like. This is a message with all properties we need. The amount, which is a KPI, the stage, which is our stage property, and the order ID, which is our process property. All others are properties we do not necessarily need for our model. If we scroll through the incoming messages, we can see a lot of different stages with also different order IDs. Those flow into the analyzer and the component uses them to build the process model. Let's now have a look how we have implemented those events in our warehouse application. Events can be received from different destinations, not just from one topic or queue. To see how it is done in our warehouse simulation, we close the flow view and open the store flow. In here, the event order received is generated. The component used for this generation is a subflow. This subflow can be found in the flow orchestrator under the name order event. If we open it, we can see a very simple flow. It receives the incoming message and sets the stage property with the flow parameter stage. Every time the subflow is used, the flow parameter is defined and set accordingly. Then the message is sent out to the following component. After we have seen now how the events are generated and how they look like when flowing into the process analyzer component, we will now see how the messages are when going out of the component. Therefore, we open the process view orders flow again and have a look at the bottom right part of the flow. After we have seen how the events are generated and how they look like when flowing into the process analyzer, we will now see how the messages are when going out of the component. This part is called process automation. It begins with the write output of the analyzer component on which the configured events are sent. Those are the stage events, alert events, and link events we have configured before. Our condition component checks here if our shipment ready event is sent by checking for the stage name and the event name. To filter out an alert, only the event name is needed. When the shipment ready event is sent, we are setting the duration as a property. This we get by the flow component path estimate. This component has direct access to the process model data and estimates the average time a message needs to get from a source stage to a target stage. In our case, we need the duration between shipment ready and shipment delivered. After we got our duration property, we set the time via JavaScript in a processor component. And finally, we can send a state with a defined message to our customer notifications panel. Our alert is directly forwarded to the panel without any additional properties. One more word to the path estimate component we use. This is one of the components with direct access to the data of the process model. They can be found under Dashboard Process Mining. It is possible to make different queries on the process model. We can have all of the or specific statistics, estimate the travel time between two stages, asking if a stage is defined, and get the stage memory with all messages in it. so we can pick every data we need to optimize the process. Let's see it live. For this, we open the flow in our flow view and click on the connection line. In here, we can see the events. This is a stage check-in event and the stage is shipment ready. So exactly what we need to send the customer a notification. This was a short introduction on how to optimize your process by using the events of the process analyzer. Besides the event for the process automation, the component provides also statistics of your process. The statistics are in the bottom left part of our flow and they look like this. Those are the statistics of the process model. They include the in transit, the alert count, the amount in transit, the total processed messages, and the amount total processed messages. These statistics are consumed by dashboard components. These components producing, as the name implies, data for dashboards. We can have a look in the editor to see how they are configured. The first one is a property probe. This component produces the totals by getting the properties and setting the field labels. Totals, in transit, and alerts are all property probes and just use different properties. The components connected to the property probes in transit and alerts are histories. The alerts, for example, are summed up and can be displayed in an area chart or similar. The stage utilization is a group chart which sums up the current count and uses the stage property to group the incoming messages. Those and more dashboard components can be found in the Flow Component Dashboard library. If we switch now to the Dashboard Orchestrator and open the Order Process view, we can see our produced dashboard data in action. This chart, for example, is an area chart. It uses the data inflow of the process in transit of the last hour, sets a label, and the chart is created. This was how to configure and use our Process Analyzer component. Thanks for watching and hope to see you next time.